Hi, and welcome to my short lecture on solving systems of equations by graphing. And I'm going to graph two different equations here. One of them is going to be y equals 2/3 x minus 4, and the other one's going to be y equals negative x plus 6. And I'm going to focus on this first one here. So I'll just move this on up here. And well, first off, let me tell you that a system of equations is really just fancy way for saying you got two equations or more. And we're just going to focus on these two equations. And let's talk about the solutions to this one equation here. And the solutions to this one equation can be represented on a graph. And that was on my previous lecture on that. So I'm just going to use the old y equals mx plus b, where b is the y-intercept, which is -4. And what that means is I'm going to start at -4 on the y-axis. That's what the y-intercept means, crosses the y-axis. And my slope in this case, the m is 2/3, which means the rise is 2 and the run is 3. So the rise is 2, means I go up 2 and the run is 3. 1, 2, 3. And I'll place a dot there. So at 1, 1, 2, 3, right there. And I could do this a couple times. I can just keep on doing it. So 1, 2, 1, 2, 3, the other dot would be there. And it makes a straight line. It's called a linear equation, because linear means you got a straight line. And I'm about to draw that straight line right now. I'm just trying to line this up. And that's pretty good. That'll do for there. And so that one's graphed. Now the solutions to this are well, there's a lot of solutions, and one solution is let's go back to y equals 2/3 x minus 4. One solution is this dot right here, 0, -4. So I'll say what 0, -4. That works in this because we can put 2/3 in for so 0 in for x is 0 minus 4. Well, 2/3 times 0 is 0 minus 4 is -4. See, so the y is -4, which is right there, and our x was 0. See, so 0, -4. That is one solution. And then I can go on with maybe this other point. I'm going to erase this stuff here, and I'll show you another solution, because there's really, I mean, how many solutions are there? There's an infinite number of solutions here. To write down that equation again, y equals 2/3 x minus 4, I can choose that point right there. And that point, the location of that point is 3, -2. So 3 on the x, -2 on the y. And I'll substitute that in. 2/3 times x, which in this case is 3, minus 4. 2/3 times 3, that's, well, that's 2, because the 3's can cancel. 2 minus 4 is -2. And so y now is -2. See, the y. And the x was 3. So 3, -2. So I mean, how many? We could do this all day, all night, for the rest of our lives. And all of those ordered pairs show up on this line. Those are all solutions to that first equation. Now the second equation, let me erase stuff here, because it's just kind of, I don't want to get too messy around here. I want to clean things up a little bit. And I'll even clean this up here. And the second equation, I'll do this all in blue. And so again, we have y equals mx plus b. B is 6, so it's 6. And then m is the coefficient of x, and the coefficient in this case is -1. And we can make that a fraction that's -1 over 1. That means the rise is -1 and the run is +1. So that means I would go down 1 and over 1 for my slope from the y-intercept, and go down 1 over 1 again. And you can do this. I mean, you can do this all day. And look, it makes a line, and that line intersects at a very special place. And so I will do this. I will draw my blue line. Oops, that did not draw the blue line. I took the ruler with it. There you go. So we have this here. Now the solution is right there. That is the solution. And the coordinates of that solution is given as an ordered pair, which is 6, 0. That is the money. That is what you need right there. That is the solution to the system. Solution, bring this over here. Solution to the system. Now, what do you mean it's the solution? It's the solution to both equations simultaneously. Let's look at this here real quick. One equation, I'll do it in red. That was the red line. That was y equals 2/3 x minus 4. Okay, and the other one, I'm going to give myself some more room here. The other one I'll do in blue was y equals negative x plus 6. So I'm saying that 6, 0 will work for both of them. So what that means is, let's go to the red side. We have y equals 2/3 times x, which in this case is going to be 6. And I'm getting 6 from my order pair. So I'm eyeing this. 6 is the x and 0 is the y. So I'm going to say minus 4, and that equals 2/3 times 6. What? 2 times 6 is 12, divided by 3 is 4, minus 4. That's the y value, so y is 0. And there you go. You know what I should do? I should actually make that green for 0. See? X is 6 and y is 0. It works. And then let's do that over here for this. We have in blue, we have y is negative x, and x again is going to be 6, and then plus 6. So y is equal to negative 6 plus 6, which is 0 again. There it is. It works for both equations simultaneously. So that's what solving a system of equations means. It means that ordered pair will work for x and y. It'll satisfy both equations, and which produces true statements. That's all I got to say about that. Thanks for watching.